So, just for grins, how many people here are developers? Okay, and how many people are here do QA work? So, all right. So, anyways, what I hope to go over here is importance, kind of stress the importance of architecture, elements of what makes a successful architecture, at least in my opinion. So, and the role that an architect can play in the organization to make the possibilities happen, and what kind of qualities are good for an architect, and what kind of challenges I face. So, personal background: I'm a software architect for the video product line at Tektronix. I've been working on the same product for 19 years. Talking about dating myself, but it's one of the reasons I wanted to give this talk, because it's been 19 years. It's the same basic architecture. It's evolved over time. But I consider that a win. You know, when you're dealing with software that has that kind of longevity, I think that's a good thing. And along the way, you know, we started out on a PowerPC system running VxWorks. We migrated that to Linux. We had a brief rotation with the ARM processor. These days, our product is running on a Linux system. So there have been some challenges along the way. We started out with a memory constrained system, so it was a small system. It didn't have a lot of horsepower. And we also did some handheld products. And because PowerPC is a big Indian architecture, and ARM and Intel little Indian architectures, you know, that was one of the things we had to deal with. It's a good thing we did too. On a personal note, I ride my bike everywhere. I commute to work on a regular basis, and I draw the line at ice. I'm also a race walker. That picture is from the Portland Marathon a few years back. So I walked the Portland Marathon. So I am a firm believer in design. And one of the things that's kind of struck me with Agile is this notion of, it's Agile, you don't have to do this stuff. I'm saying, yes, design matters. Especially when you're scaling up. Because when you know, with a simple thing, with a simple software, you can just discover that design. It can just come to you. But when you're dealing with scaling up to large scale, when you're talking millions of lines of code and complex systems, you need to have some forethought, some planning involved in there. And what an architecture provides is that conceptual framework, this roadmap. You can drive without a roadmap, and you can also get lost. So the architecture is that roadmap, and it's something that helps coordinate the system design. So you have this framework, and within that framework you can have individual designs or component designs. And it also provides that common infrastructure, that level of consistency, and also a level of reuse. And I think that designing large systems requires a lot of teamwork, because it's not just one person designing, it's everybody designing and coordinating those designs together. And that, you know, we're people. We have different thoughts, different biases. We think differently. So if we're, you know, this difference of thinking, this different ways of thinking gives us lots of creativity. But it also can generate a lot of chaos if we don't manage it. And so the architecture helps focus that energy, helps us be creative without losing sight of what we're really after, and without, you know, you could have two very elegant designs that are just totally in conflict with each other. And so we need to choose a path. We need to work together, and that's what I see an architecture as doing for us. And architecture is also a focus of discussion. When we're talking about what the general shape of the system is, then we can have discussions about it. And once we, you know, when we put it down on paper, we can, you know, hash it out. We can, you know, mold it, and we can work it out. So one of the important aspects of an architecture is it defines the hierarchy of the system. Who has control of what. And I chose this picture here, of someone driving a car. And I found this picture and I'm thinking, oh geez, that shouldn't be a BMW logo there. That should be a Toyota logo. Because if you remember a few years back, Toyota had this sudden acceleration problem. And that's, and there was this report, the Bar report, that just grilled Toyota for all their flaws in their development. And one of the things is that if you do not have an established hierarchy, then you get race conditions, where you have competing agents within the system saying, I'm in charge, no, I'm in charge. And the results are unpredictable. It's very difficult to find these sort of things, because, you try to put in the debugging code and you just change the behavior of the system. So now it works. You take the debugging code out, it doesn't work. Or it works sometimes, but not all the time. So just really difficult stuff. The other important aspect of an architecture is modularity, and that things are structured. Things, there are pieces, and the pieces come together. They work together. And when you get large systems, you really have to have that modularity, and that modularity gives you reuse. It gives you testable units of functionality. You can actually have unit tests on units because you have modules. And if you don't have modules, well, you get spaghetti code. And when you start piling on software, and there are all these pieces in there, and they're in there, but if they're all in one big lump, then those connections between the pieces increases that in log n. And you also have to account for what happens when a user selects something, what happens when there's an error in the system. It's something I looked up. So, I was looking for a number there. It's more than linear. And it's not quite square, but it's just, it's just this notion that you add pieces, and those pieces talk to each other, and it's not just one to one, it's one to many. And so you see where the complexity goes. It's, you add these pieces, so you have modules, and then you have defined interfaces on those modules, and the modules talk to each other through known methods, and that helps organize your code. Simplicity. I have looked at code and I'm going, oh my gosh, what is this mess? Where's the structure? Where's the, and why do they use single letter variable names? And of course, simplicity, it's an easy concept. It's easier to understand. It's easier to explain. It's easier to use because, you look at it to see what it is. I think it's a hallmark of elegance, but it takes time to tease out the simplicity. You can't just go and start hacking at it and come out with something simple and elegant. You have to kind of think about it, think about the patterns, and and sometimes that simplicity isn't just on, maybe it's just on the outside. You provide a simple interface to something that's very complex. But you provide that simple interface, and they don't have to deal with that complexity. It's like we're using these phones, these mobile phones that we have. They're amazingly complex devices full of lots of modules and systems, and we're building on top of it. And I find that it helps to start on paper. Write it down. Just because if you don't like what it is, you erase it, or you throw it away, or you start again. But it's on paper. You're not committed to it. But once you start coding, it's like, oh, I've got this code. And it's like, I'll just add to it. I'll just add to it. And then you can just kind of lose your simplicity in all this pile on stuff. So when I'm faced with this complicated code, do I take one for the team? Or do I just run away? That's my first impulse. Run away! Run away! So, and the other thing is that any product is is this combination of all these different requirements, sometimes competing. You know, you have the business needs, you have the customer needs, you have the needs of the developers. Sometimes you have regulatory requirements or industry standards. And so all of these combine. And so the architecture has to balance these needs. You know, what may be good for one thing may not be great for the other thing. So as the architect, you have to decide what's important and what's the proper balance of things. And the architecture also makes the early choices. You know, and it sets the direction for the entire product. And you know, once you set in the direction, it's kind of difficult to change everything. So you kind of want to get that direction right first time. I have found through observation that the worst thing that companies can do is build a platform. And I've seen this play out. You know, it's like we decide, yeah, we're going to build a platform. Our future products are going to be based on this platform. What are those future products? We don't know. We haven't really thought about the products. You know, the thing is, I've seen also centralized platform development, where you have a central group. That's like maybe there's an edict from management that's like, thou shalt reuse code, so we're going to create this platform. But you have all these competing interests. You know, you have multiple stakeholders, and sometimes that group is just isolated. So how do they know what the customer is? Because after all, the end product is, what does the customer need? What do we deliver to the customer? What does the business need? And I've seen this play out. It's, you know, you have this platform development. The architect's going wild because, gosh, I get to do all these things. You know, we're going to put this stuff in because we might need it. So we throw in everything, including the kitchen sink. And, you know, and so we deliver too much, but not enough. You know, too much of stuff we don't need and not enough of stuff we really do need. And so how do we focus that architecture? How do we focus that design? And what we happened upon in this architecture that we developed, we had this choice. We actually had this architecture that was developed specifically as an architecture. It was developed in an architecture development project. And we didn't use it. It was too expensive. You know, and we looked at it and said, there are some serious flaws in here. It doesn't work right. One of the things was it had a central database, and you locked the database and nobody could access it, so that impeded the performance of the system. Because while you were changing something in the database, you locked the database and nothing can use it. And when you unlock the database, everything had to figure out what changed. So we took that different approach. In our system, our mantra was product first. But leave the door open. Leave that flexibility in there to account for the stuff we don't yet know about. That strategy worked for us. It's worked for us for 19 years. And so the architecture evolves. So the architecture is the same as it was. It has data tags to define the data. It has messages, and we decided that messages were very good at coordinating the system. The messages were atomic. We identify through these data tags, these definitions of what the thing we were going to change, and we find those things that changed to be, you know, individual things that didn't have a whole lot of effect on other things in the system. And then the message type was the action. And we started out like S&P with get and set. And you know, you get something and you get back a result, or you get back an error. And you set something, you get back an ACK, or you get back an ACK. Then in our system, we needed alarms. So we added alarms. And then sometimes the things had side effects. So we added status messages. You set this one thing, this affects the other thing. So it sends a status message to say, hey, I changed this thing. And so this type of system has evolved for us. And so as we needed more actions, like we needed a post operation. So the post operation didn't expect a response. We just send it out there and intend for it to do what it needs to do and don't bother us. And so that helped efficiency in the system. So, kind of changing tack here. It's, how does the architect fit into the system? And I think of a traditional Scrum team as, being one product owner. Product owner represents the customer. Their focus is on what does the customer need. And often that's customer needs this feature and that feature. And that's what we typically hear from product owner. And the Scrum Master is in charge of ensuring the process all works. They're supposed to work with the product owner to prioritize the backlog, to make sure that we're working in things in the proper order. Which features are we delivering in the proper sequence? And our velocity is usually measured in story points, of course. Then there's the development team, and their responsibility is to build the product, to put the features into the product. And they're also, they're responsible for configuring stories. They're also responsible for the technical debt. Those are the ones that can add technical debt or remove technical debt. And their efforts are typically measured by sprint velocity. And there's that, I passed by the table downstairs, and there's a placard there that says, who is responsible for quality? And well, everybody's responsible for quality. But who speaks to the quality? And I'm proposing that the architect is someone who can speak to the quality, the needs of the architecture. Because the architect's focus is delivering that architectural vision, this design that we've carefully crafted, and trying to ensure that we implement that with integrity. The architect is often part of the development team. The architect may be part of a central group also that's loaned out to the product teams or works with the product teams. One of the aspects is that the architect also can engage early, because when you're setting out that roadmap before the development starts in earnest, to work with the product owner, for example, to develop requirements, to work with the development team to develop the architecture, to figure out what the architecture needs to be, and to work with the Scrum Master as part of the early representative of the development team to work out t-shirt sizing, or rough estimates of what the scope of that work is. As we're figuring out the architecture to lay out the scope of that work, we can start trying to estimate what it will take to build that. I find that quality is a hard thing to measure. Yeah, you can measure bugs, you can measure technical debt, how much technical debt do we have in the backlog. But how do you really measure the quality of the system? Because the technical debt is a lagging indicator. But I'm thinking that, if you look at the design of the system and see how closely it adheres to what we intend it to be, what the design, the architecture is, that's an indication of, the kind of quality you have. And that consistency, adhering to that architecture, gives us consistency of the system. And that consistency produces fewer surprises. Allows us to, and those fewer surprises means fewer opportunities for defects. So if we're looking at the code and that code is like this code, it's familiar to us. It's also provides reuse, because if we know what what the system is supposed to look like, we can identify pieces that are shared, and we can share them. And I look at the architect as the guardian of the architecture, not the owner. The team owns the architecture, but the architect speaks on behalf of the architecture. And I think it's very helpful for the architect to review code and design. At least I've found it helpful, because it allows me to see, what people are doing in the system, and how closely it's adhering to the concept that we all thought of. You know, I think, I was thinking primarily developers, but yeah, QA people as well, because, we all live in this ecosystem, and it's like on our product, we have a web-based interface on our product, we have Selenium running, and so the UI folks are working with the QA folks to make sure that we can test that. But, it's an important consideration, too, that, the architecture should support testability. So in terms of requirements, I have found it really helpful for the architect and the product owner to write the requirements together. In fact, I find it useful for me to type out the requirements and for the product owner to say, yes, that's what I have in mind. Because one of the things that an architect brings is kind of this technical rigor. Because the product owner is often, at least for us, he's marketing. He's an expert of what the customer does. And the architect is a technical person. And as a consumer of requirements, architect knows what's needed, what he needs to know, or what she needs to know from the requirements. And also non-functional requirements. We often think of in features, but what about performance? What about cost? What about, expandability? Those sort of things. And one of the things that the architect has to do is have to evaluate, to test it out, test out the assumptions, prototype. Because if you don't get that right, bad things happen. And I've seen this one play out. I saw this thing play out from the sidelines because we had someone else who was architect of the, or at least the management decided that we were going to fork the product. We're going to have a new product, and this product was going to have Java. It's going to run an ARM processor. And maybe some of you are thinking, ARM processors. Well, slow CPU, but more importantly, they don't have floating point. And Java likes floating point. And so if you don't have floating point hardware, you're emulating floating point software, and it's really slow, a lot slower. And the ARM processor didn't have a very good context switching. So context switches were expensive. And the flaw here was that the architect, he liked Java. He wanted everything to be Java. And so he did this performance evaluation. He did this prototype, and yes, it's working as I expected. It's doing as quickly as I expected, but that was just one thread. You throw in about 30 threads, and things look different. So there was a flaw in the evaluation of the architecture. And the result was poor performance, extensive rework. We went through at least 2 different Java libraries because once we discovered that the flaw was that the floating point made the library slow, we had to find a Java library that didn't use floating point. And so everything had to be migrated. And there were lots of weekends. And before the product even shipped, we had plans on how to remove it. So Java is not, you talk about Java and there's like, oh, what, Java? Really? No, we're not talking about that. Important delivery for the architect is the document, the architecture document. Because, if it isn't written, it doesn't exist. It's just it's a thought in someone's mind, and who knows what that thought is. But if you put it down on paper, if you commit the words to paper, or, Word document at least, you're putting it out there so people can critique it. And, an architecture document should be well written. It should remove ambiguity. It should be something that promotes discussion. So, once we say what we intend, then we can discuss what it should be, and thereby make it better, and make those trade-offs. Make those trade-offs that we need to make the architecture better. And the architecture document should be stored in revision control. It's like all our source code is. The architecture is a vital part of that product. And so we need to store it in revision control, because if we don't, we'll lose it. We don't know which version of the document is good unless it's in revision control. And it also gives us a perspective on what the history of that document was, how it changed, how it evolved over time. And also that document is valuable for onboarding new people. This is what the system looks like. And we can explain it to them. We can provide the training. We can point to the document and say, this is what we intend. Another important thing that an architect does is determines the tools and environment. Because that goes along with the architecture. It's the structure, also how we build it. So if you choose Java, then you're using Java tools. If you're using C++, you're choosing compilers. And I mentioned here this myth of embedded development. I keep on finding this around. It's like, and the importance of tool choices. And so embedded community is saying we don't want C++ because C++ is too expensive, and we use C because it's efficient and we need it. And I'm thinking, you don't need to use C, but there are benefits from C++, like type checking. And it only costs you for what you use. And also, I find that object-oriented programming is great for modularity. And it's kind of amazing how many people are just having difficulty wrapping their heads around that object-oriented programming. Also, build or buy. That's frequently a question that we get. Do we build it? Do we buy it? And I'll point out that open source is not free. There is a cost associated with it, and the cost is your time, because someone has to maintain it. Somebody has to keep it current. And of course, if you make good choices, they save you time. If you make bad choices, well, you're kind of stuck with them, and you have to feed them, and that each time. And so, another personal experience. In this case, it was early on in our product development, and we reused source code from another product. Its interface was written in C. But instead of one display, our product had 4 displays, and instead of having objects for each of those little tiles on the display, the designer decided that there would only be one type of display, but 4 entries in that display for that. So parameters got multiplied. This was an amazing spaghetti. It was just all over the place. It's like we had things happening. We did this over here and this changed over here. And so it wasn't modular. It wasn't compartmentalized. And because we were doing it in C, it was kind of this functional approach. So we had one function with multiple parameters. So we undertook an effort to change all of that C to C++, to define objects, to define hierarchies, to define constructs. And the first thing we did was we changed the filing extensions from .c to .cpp, and recompiled the whole thing and took care of all the warnings. And that cost us 3 months' work. But you remember that Java stuff I told you about? Well, we were looking from the sidelines, and these people, they were just saying, do we just tell them to kill that thing? Because they put so much effort into it. But we offered them something. We did this work in changing our UI. And we said to them, here, use these. You can use these in your product, because we've done the work to make these something that you can reuse. And that helped the product. That kind of brought it to market quicker, and then this took over. These days, C++ 11. We started a new effort, we started a new product, We updated the architecture, C++11. I like C++11. You got threads in the standard library. You got shared pointers. The standard library is part of the language. And so we have standardized in C++, version 11. And I find, as an architect, it helps to be part of the implementation, to feel the pain, to eat the dog food. You know, it gives me firsthand knowledge of what works, what doesn't work. So if something's not working for me, and it's like I can see it, and I can understand it, and I can change it. Also, architects tend to be senior members of the team. And having the architect there with the complex parts of the system, knowing what's supposed to be, this is key parts of the infrastructure that I took it upon myself to put into the system. And I said, architect is, guardian of the architecture. And by what I mean is that, to help it belong, to shepherd it, to safeguard the architecture, to make sure that the architecture lives on with integrity. The team owns it. But, somebody has to speak for what that intent was, what that vision is. And there is no perfect architecture. If there was, we'd all be using it. But each architecture is, determined by the needs of the team, of the product, of the environment. And sometimes I feel it's important to just say no. But if I say no, I have to say why. Our keynote address, told us, ask why. And I'm saying, yes, you should ask why, and I should tell you why. Because for every decision in the architecture, there should be a good reason behind it. If there isn't, well, maybe we need to think about what that architecture should be. And also, provide guidance. If I, as an architect, think that, that this is the vision of what the architecture should be, and I can say, well, here's some suggestions. Here's how we can make this happen. And I feel that the value of the architecture is how long it lives. Its value is in its reuse. As I said, 19 years. I consider that a big one. So, an architect. An architect is a seasoned technical leader. Someone who has experience, who can relay that experience, to work in details without being lost in those details, to be able to focus on the crucial things, and defer the things that don't have to be dealt with right away. And feel the architect needs to be organized. Need to be organized so that we can organize the design, to make it palatable, make it so that we can communicate it, so that we can make it understood. Because really we have to, we all have to understand what the architecture is, understand that vision. And we communicate that vision to others. But we also listen. We listen for that feedback. Because as I said, there is no perfect architecture. And we incorporate the best ideas. We negotiate when we have to for those trade-offs, identify those trade-offs, pick the best path forward. Do that as a team. Be critical. Ask, could this be better? To be humble. Because it's a team effort. So, I said it's helpful to have the architect be part of the team, part of the implementation. And sometimes there's just a lot of time to market pressure. Sometimes management says, we need that product out now. It's like you did that prototype, and the team's going, oh, that prototype's disgusting. We don't want to ship that. But, markets, management says, we need that product now. Our business depends on it. And, we can measure the sprint velocity. And I find the sprint velocity has a lot to do with how many features we deliver. But we also have to, be able to identify what our technical debt is. And that's one of the things that we're having to discuss. And our development team is saying, we need to identify the technical debt. We need to be able to address that technical debt. We need to be able to build infrastructure without this relentless pace to deliver features. And there's always a next project. But, as an architect, I want to be engaged in the next project. But there's also this pressure to be working to finish the current project. So how do we balance those two? And also, now with, at least in our environment, we have a team in India, for example. And so we have distributed teams, and we have to communicate with them. And here an architecture document is helpful because you can deliver the document to them. You can explain the document to them, and they can refer to that document. But it's kind of difficult where you have that time lag, among other things. And you're only talking with people by phone. You don't really have that face-to-face. So, architecture is a roadmap for development. It's a high-level perspective. It helps guide the development of that product. It allows the developers to focus on providing value. I think it benefits from an evolutionary approach. Not the, we know everything there is about the product, so we can define the architecture up front, but rather we build the architecture to what we know, leave it flexible enough to account for what we don't yet know. And the value of the architecture is demonstrated by its acceptance and its reuse. And I think an architect plays a key role in fulfilling the promise of the architecture, helping to guide that architecture, to be guardian of that architecture, to protect its integrity, promote consistency, to be a good role model, for other developers. And I'm a firm believer in design. And I think that quality software follows quality design. And so, I put a couple of other extra links on here, put QR codes, because I didn't put them in my paper. But one I found was an interesting article I read on LinkedIn. It was the engineering manager, I believe, who was talking about a Bet the Company affair on LinkedIn, where they had this problem in their environment that was going to kill their company if they didn't take care of it. But they had a massive undertaking. They came through it. They survived, and they were stronger because of it. The second story, not so great. This is the Toyota sudden acceleration problem. The article was Toyota's killer firmware, bad design and its consequences. And it's an article about the Bar report, which is just scathing. It's like Toyota didn't follow the architecture. They had coding standards that they did not follow, and they had race conditions all over the place. So, questions? Yes. Mm-hmm. Yeah. Okay, so how do you push back against that Manager saying, get it done at all costs. I have this little story. I had this engineering manager. He was in my cube, and I was saying, there's this security flaw in the product. We need to fix this. And he said, well, this is going to take time away from features. Which is more important, the features or fixing this? I knew where he was going. I said, fixing this. He looked at me like I grew a horn out of my head. But you know, sometimes it's just, you got to speak to it. You got to say, this is important. And at least in my group, the team understands that. You know, the developers understand this. And they see the problems in the system. And they say, we need to fix this. In some cases, you need to kind of make that economic argument too. It's like, we fix this now so we don't incur the cost later. And where we had this UI problem, the UI problems were inherent in the product. And we said to management, look, we need to redesign this. We need to re-architect this thing. And it's going to take us time. And in that case, management said, okay, yes. But it's everything's a struggle. To be able to point out what's needed. And, part of that is to, be able to make that case. It's like, we need to do this because. So, develop that answer. I wish I were. But partly it's like everybody in the development team can be an architect for the future. And I think one of the vital mechanisms we have is code reviews. And I and another team member who are very concerned about, good structure, good design, and we'll point out in the code review. It's like, if you did this way, it would be better. And so that's my answer to how do we groom the architects of the future, is we groom the developers of today to make them better developers, and then they grow up to be good architects. Thank you.